Right, so when you're looking at these regular polygons, once again, we've already discussed the equilateral triangle and the square. What is the sum of the interior angles in a triangle? 180, right? And in a square it was 360. Okay, and both of these we're already aware of. Each interior angle for a regular triangle, what is each of these angles going to be? 60 degrees, and for a square, each angle is 90. So what did we do to get from the sum of the angles to each individual interior angle? We took the sum, divided by what? Divide by the number of sides. So the number of sides is 3, number of sides is 4. And so this gives you your general rule. Each interior angle of a regular polygon is equal to the sum of the angles, which is n minus 2 times 180. We talked about that last class. Divided by the number of angles, or the number of sides in that. And so this is your formula for finding what each interior angle of a regular polygon is. So if I wanted you to find each interior angle for a 23-sided polygon, okay, what would be each interior angle for that? See if you can calculate that here just really quickly. So you got 164.35. Okay, so what you did is you entered that into the formula 23 minus 2 times 180, all divided by n. So, all divided by n, the number of sides, 23, and that gives you your value. So again, if I were to calculate that, 23 minus 2 times 180 divided by 23, put it in decimal form. Okay, so there's my answer. It doesn't make sense. Would that be an angle that you would expect with something 23 sides? It's getting closer, it's getting larger and larger, right, as you increase. Okay, let's talk about each exterior angle. Okay, so we saw that each of these interior angles was calculated in this fashion. We took the total sum of them divided by the number of sides. Well, what is the sum of the exterior angles in a triangle? 360. What about a square? 360. Doesn't matter what, right? It's always 360. So if you do this same kind of calculation to find what each one is, what you wind up seeing is the sum of the exterior angles divided by the number is always going to equal each interior or each exterior angle. So for this triangle, 360 divided by 3 is 120. 360 divided by 4 is 90. Does that make sense? Exterior angle compared to the corresponding interior angle need to be related how? Here's your exterior angles. So an exterior and each interior have to be supplements. A linear pair is 120, the linear pair of 60 is 90, the linear pair of 90. Yeah, so that relationship will hold true. Okay, so if you were to calculate 360 divided by 23, you should get the supplement of 164.35. So we can check that. 360 divided by 23, put it in decimal form, we get 15.65. Okay, and is 15.65 plus 164.35 equal to 180? Yeah. Okay, so you can kind of pick and choose which one to use. Usually this exterior angle is going to be easier to use when solving for missing pieces or missing angles. Okay, you guys have, so if you do the same idea, you're given the interior, so let's find the corresponding exterior angle is going to be what? 30. And so if we plug that in, and again, if we just take 360 divided by 30, that's going to give us n. Okay, and so what do you get for your solution? 12. So we're looking at a regular 12-gon. There is a name for it, dodecagon. You don't need to know that. If you just put 12, you're okay. All right. What if I asked you the following? Exterior angle is going to equal 50, so we can use that for simpler calculation. 36 divided by 5 winds up being 7.2. Can you have a 7.2 gon? Can you have a 2/10 of a side if everything's the same length? No. Anytime you get a decimal, if you're looking for n, if you're trying to find the letter n, decimals represent that is not possible. There is no regular polygon whose interior angle is equal to 130. Okay, so that's a potential answer for any of these problems that you do from the 7.2 work. If it doesn't fit the calculation, it's not possible.